How does quantum mechanics affect free will and determinism? Imagine a universe where the tiniest particles behave in ways that seem almost random. This idea is at the heart of quantum mechanics, a science that changed how we see the world. In the early 20th century, scientists discovered that at the smallest scales, nature does not follow strict rules. Instead, outcomes are described by probabilities, not certainties. This shift from classical physics, which believed everything could be predicted if you knew all the details, was a major milestone in science. Quantum mechanics formulated concepts like wave-particle duality and the uncertainty principle, showing that particles can act like waves and that certain properties cannot be precisely measured at the same time. These discoveries revealed that matter and energy are fundamentally unpredictable at the quantum level. This unpredictability has big implications for ideas about free will and determinism. Classical physics suggested that if you knew the exact state of everything, you could predict the future perfectly. But quantum mechanics introduced indeterminacy, meaning some events happen without a clear cause. This randomness might seem to open the door for free will, but it's not that simple. Random events are not controlled by conscious choices, they just happen by chance. So, quantum indeterminacy alone doesn't mean humans are making free choices. It just means some things are not predetermined, but not necessarily under our control either. The role of the observer adds another layer to this puzzle. When a scientist measures a quantum system, their choice of what to measure influences the outcome. This suggests that human decisions could have a fundamental effect on physical reality at the quantum level. However, this influence does not automatically translate into free will. The outcomes remain just probabilistic, not directed by conscious intent. So, while quantum mechanics challenges the idea that everything is fixed from the start, it doesn't fully explain how free will might work. The development of quantum theory marked a major milestone in science by questioning the old idea that the universe is a clockwork machine. Instead, it shows that at the smallest scales, nature is inherently uncertain. These discoveries have influenced philosophical debates about whether humans have real control over their choices or if everything is just a matter of chance. Technologies like quantum computing and quantum cryptography use these principles, but they do not directly prove that free will exists. Still, understanding that matter and energy operate under probabilistic rules helps us think differently about human agency and the nature of decision-making. In the end, quantum mechanics introduces a new way of looking at the universe, one that includes randomness and unpredictability. While it challenges the strict idea that everything is predetermined, it does not automatically give us free will. Instead, it opens up questions about how chance and choice might coexist in the fabric of reality. These scientific advances continue to shape how we see ourselves and our place in the universe, offering a fresh perspective on age-old questions about human freedom and the nature of reality itself.